Hi guys, this is my first video of this channel. I am a PhD student and I'm gonna explain here a little about my research and finite element method. And the focus of this channel is to present the difficulties that I have and the things that I learn and that I see that are known on the internet, and I think that could be better explained. So the first one is about the Darwin formulation in finite element method. I I am like an author from this repository in GitHub that use GetDP, that is a solver for finite element method, but the documentation is very poor and is very outdated. So the things that I hear have a lot of changes. You could see the tutorials from here, and here shows a little of work developed day by day, but it's very difficult to understand and to implement these things. And to myself, I use entirely on transmission line parameters. So I have a soil and I have the interference of the permittivity, the permeability, and the cable. So I try to use finite element methods to submarine cables with a lot of layers, so like 10 layers, 9 layers with different soils. You can basically create the environment what you want. You create like a 2D, but you can't create a 3D because the mesh from this is OnLap is the wrap. So I have like G mesh, that is the mesh, and I have the GetDP, that is the solver, and everything this is connected with OnLap. So here we can show a lot of examples and tutorials, and there are a lot of tutorials from the GetDP. The idea here is not to show that, is to show the Darwin formulation. The Darwin formulation, I use basically this one. I will show like just the yeah, here is basically on the API from GetDP. But basically this is the formulations from GetDP, and I have a lot of definitions here: the constraint, the function space, the Jacobian, the integration, the formulation, and this is the formulation that get me like giving me a lot of work to understand. So everything about that is basically the formulation. I am not going. I could post a example that I have, and I you guys can understand like the whole example, but just gonna to show the formulation here, and I use another like GetDP is just the APE that I use, but I use the line cables models that call GetDP, and we can process any cable and anything that you want. Is on electric grid here, and you can access. This is open source, and you can see. But the main topic here is to explain the Darwin formulation. So you guys could see here that I have a null and dot that degree of freedom. And when you guys try to understand by the Maxwell's equations, you gonna think that is a full wave, but it's not a full wave because it's a 2D model. So let's explain the Darwin formulation. So these are the Maxwell equations. So I will not explain them, but you guys can like make a representation assuming a linear isotropic medium, and this is the constitutive relation that you can use. And basically we're going to use the current density, and we are using like the electric field like that and the magnetic field like that. So what we're gonna do is like writing in terms of the A, that the vector magnetic vector potential and the scalar potential V. So we use like this equation with this equation to become this equation. So with that, we're gonna use the Gaussian's Coulomb gauge, and with this we can apply the Ampere's Maxwell law and obtains this one. And this is the complete Darwin, the complete full wave that we have. But Darwin made an approximation based on the frequency, because this term here is the Darwin term. And this term, when we have like, this is very tiny. But when we have like a high frequency model, this guy like will represent more about the the physics of the how to say that, the experiment. So to understand that, I'm gonna jump to that. So I have an electric field and a magnetic field, and this this is a variant, so this is gonna like induce a current J, and this current will produce a magnetic field and electrical field. And this electric field are gonna to induce and what like how to say this is like they will induce these two fields, and this will generate another current density in the medium, and this is gonna like make all the parameters different. So the idea is to, in a 2D, this is very important, in a 2D formulation, we don't necessarily have have this term, because will be like induced in the z axis. So with that, in the Darwin formulation, in the GetDP that I show you guys here, they use a 2D formulation, but they calculate the Darwin term from the z-axis to induce and provoke a different inducent density here. And this inducent current here, inducent current density, are gonna be different because they have this modification. And this modification shows by research that is more like more complete, more realistic of the model. And I show you guys here how the idea of the formulation. This is written by myself and physics, so this is already checked and is valid. And this is using like a complete Darwin approximation. So I am disconsidering this part here. Okay, but in my formulation from GetDP, I use this Darwin formulation, this Darwin term, to impose artificially this effect that I explained to you guys. So this is the video. I'm gonna put this test PDF to your access and read, and I'm gonna put the case for GetDP to in on lab to you see and understand. Bye guys.